Hello, GIS students. This is Lab 2 for Advanced GIS, and we're going to be doing topographic differencing in this lab. And so I just wanted to start off by showing you kind of the lab, how to get started and whatnot. So we're working on Lab 2, which is sitting in weeks 3 into 4 module of Canvas. So you can open that up and you'll see that I've got the lab document here already opened. And also I've got some links to some videos within that lab assignment, which might help. I'm going to be adding more videos, including this one here, that are more specific to these lab. But these are here as a secondary help for you as you learn to kind of mosaic rasters, clip rasters, and do profiles. But we'll do some added videos on those here today. Also note that I've provided this Cedar Valley area KMZ file that can be downloaded as a template for where to get your data for this lab. In the lab, we're going to be looking at topographic differencing of Cedar Valley down near Cedar City in Utah. This is an area where there's one LiDAR data set from 2011 and another from 2020. We're going to difference those from each other, as well as other data sets, such as a 5-meter topographic data set that's made from overlapping air photos in 2007, I believe, and then an earlier DEM from the USGS called the National Elevation Data Set, which comes from a variety of data prior to 2004. And you're going to basically choose some area in this region here to do topographic differencing. This is a map of topographic differencing here in Figure 2 that a student from last year produced as they got ready for their AGU conference presentation on this topic in ground subsidence in this region. So there's areas of topographic change that we can see right away. Some areas are up and some are down, have experienced subsidence due to groundwater pumping, and other areas have experienced urbanization and one change one way or another. And so in this lab, I asked you to look at one of these 3 subsidence areas, either Enoch Valley, which is probably the one I'd recommend. It's maybe the most simplistic, Parowan Valley, or Southwest Cedar Valley. Parowan Valley and Southwest Cedar Valley are a little more complex because there's a water feature in those areas as well. And so Enoch Valley is a little easier to deal with. And then the area for best kind of development change, so in addition to subsidence, ask you to look at development, would probably be the area near Cedar City. But you could also look at agricultural areas and see what's happened there with agricultural fields and roads and potentially other things such as topographic change from channels and things like that. So subsidence and something else with landscape and urban development. So you can choose whatever size study area you want, but you're going to want to be careful about that because you need to difference each of the data sets over the exact same area, because I want you to fill out this table, which also shows us some attributes of those different digital elevation model data sets and their derived products such as slope over the exact same area. So we're going to make a clipping mask to make sure that works. So you don't want to do the whole region. That's just so much work to download all the LiDAR because you can't get it in one shot. And so you want to be smart about where you pick these. Where are you going to download this data? I've got links for that here. National Elevation Dataset, AGRC autocorrelated dataset can be gotten from the UGRC Raster Data Discovery app. What you do is you go here. You can also get LiDAR here, but in this case, I'm going to select USGS DEMs and autocorrelated DEMs. And that's what it's going to look for. Then I click Define Area of Interest. I always like to use this Draw Polygon field. And then I go to where I know Cedar City is, and I circle the whole region. And then it shows me what I got. And I ask you to get the 10-meter and this 5-meter data. You drop that down, it shows you it's USGS DEM, drop down again, click this download link, and you see the tiles that are available that you would have to download. And so the tile that you're probably going to want to use if you're studying Enoch or the Southwest Cedar Valley area, you'll get this tile right here. You can click on it, right click, save link as, and then I'm going to put that into my OneDrive under Lab 2, save it there. Boom, I've got that. Now, the other data set, go back to results, go to the 5-meter autocorrelated, click download, and I see that there's this other tile system. It's smaller because this is higher resolution. Here, I probably need to get a few data sets. I'm going to go, let's see. Yeah, I think I'm going to get this one. Save link as. I'll put that there too. I'm going to get this one here. Oh, I didn't get that right. Right click on the tile, save link as. And then I'll get this area. And I'll also get this area. So I got 4 tiles. Okay, so that's where you can get those 2 data sets. I recommend for the LiDAR data sets, you can find those on UGRC, but they're going to be smaller tiles that you're going to have to download. So you have to click more downloads and do more kind of raster mosaicing or merging. And so to do it more efficiently, you should use Open Topography. Open Topography is a great website to download LiDAR data from. You should, and you kind of have to, register with My Open Topography and sign in with your .edu email address. This will allow you to download seamless data from the National Elevation data set that is high resolution and basically LiDAR derived digital elevation model. And so we click find data on a map once we're logged in, and we'll zoom to Cedar City. And you can see the outline areas of some of the data sets. So like this by color. So you can see Open Topography has this red data set that covers all of this region. I think that's most likely the 2011 LiDAR data set. And if you then select a region, we can see what else is there, because I can see some other colors overlapping. And so I'm going to zoom in again, and Enoch is the area of interest for me, and Cedar City. So I'm going to do a little thing like this. Okay, so I can see the Utah Geological Survey LiDAR. If I plus that, I can look down here and I see that it is the 2011 data. So if I want that, then I click point cloud and it carries over my selected region, but it's going to give me some issues. So if we scroll down, it tells me that I've got too many points. I'm only supposed to collect 250,000 points in one processing job, because what's happening here in Open Topography is you're actually sourcing the original LiDAR data, which are points, and they are interpolating, like we did in Lab 1. Instead of rainfall data interpolation, they're interpolating the elevation of the landscape. So here's a little hint. So one, you can ask power user status, but this usually takes a couple of days, and that doubles the points you can process. But another way to minimize your points is to change it from return classification of ground and unclassified to just ground. And then now it says, oh, look at that. I'm good, 240,000 points. Okay, so I'm going to look at that again and then think about it some more. Maybe I want to slightly adjust this since I have more space, and maybe I've kind of gone too far outside of what I really want. So I'm gonna choose mine to be maybe more like this. So I'm gonna make it a little less northerly. little wider here and here. Okay. And now I've got too much, so I have to kind of do this iteratively. So I guess I'll choose this bend in the road here. Oh, that didn't work. Got to start from one side to the other. Okay, so I'm going to start from here. Ugh. Okay, I'm only going to go so far over here now. Is that better? Let's see. Oh, goodness. Getting too greedy. Okay, 211,000 points. I'm going to go with it. Okay, so I've got ground classification only, not unclassified points. I do not need the point cloud data for this, but you have to select one of these because you are doing a processing of a point cloud. You don't have to download it after the fact. From experience, we have several options here in terms of digital elevation model generation. We can calculate a TIN or we can do local gridding. I know that this data set is actually pretty sparse. And local gridding, most of it has like a radius search value, like an ID inverse distance weighting that you have to analyze to kind of like make sure you don't get holes in your data with local gridding. Whereas TIN, we're more likely to have less holes in our data if we use that. And so I'm going to use calculate TIN to generate my digital elevation model. That's going to be my interpolation method. I'm going to produce it as a geotiff. And I'm going to look for 1 meter data in this case, and I will keep this as the default triangle size. In addition, I'm going to ask them to give me a hillshade. I will stick with the defaults here. And yeah, I'll just keep that hillshade because that'll give me something to inform my choices later on in the lab. And actually, I should do something else. I could have them build me a slope model so I don't have to do it myself later on in ArcGIS Pro. You can do both of these things here. That's part of the democracy of using open topographies, bringing GIS without a lot of processing necessities to the masses. So we could choose those and it'll produce them that we could download and upload into GIS. If you want to know what the point cloud looks like, you can also choose this generative 3D point cloud visualization. That's kind of cool. I'm going to click it right now so you can see that here in this video. And that's it. I'm going to give it a job title. I'm going to call it 2011 Cedar Valley Tokay 1, in case I have to do it again, and submit. Okay, so it's doing this. It'll send me an email when it's ready. In the meantime, I'm going to go submit another job. I'm going to go find data again. This time I'm going to go back to the same place. And I'm going to select roughly the same region. Now what I want is this 3-depth data, the second one. And what we want is this USGS 1 meter digital elevation model, academic access only. And we'll click that. Then it shows that, this isn't all available yet for the entire country. Let me zoom back in. It forgot my search area. But I'm going to try to roughly get the same area as I got before as best I can. Oh, annual basis. Click the button, enable access. Okay. Excuse me, I haven't logged in a year apparently to this. So I'll sign out, sign back in, and see if it works. You can see all my old jobs here. So hopefully it now will give me access, but let's see. So I'm gonna try to select that region again, 3-dep. Okay, good news is it's got me logged in. Okay, so then I gotta make this smaller. I can only do 500 kilometers squared. Okay, I think that is, oh, I can make it a little bigger. Okay, let's select that and proceed. So I'm gonna take their geotiff. I'm also gonna take their slope shade and their hill shade, and I'm gonna call this 2020 Cedar Valley LiDAR. Submit. Okay, so now I'm gonna go back to my open topo, and I'm gonna go to my previously submitted jobs. And we can see that the first one is still processing. So we're going to have to wait on that. But one thing that you might do in the meantime is click on full job metadata. This metadata tells you important things like the vertical coordinate system and horizontal coordinates, which I ask you to fill out in this table, vertical datum. So if we go back here, we can see the vertical datum for the 2011 LiDAR is NavD, 88 is the coordinate system, and the vertical datum is the geoid 09, EPSG 5703. So put all of that in there. We're going to see how these compare and think about that as we go through the lab. Okay. And so, yeah, you might want to save a link to this, download it up here, save it in your lab. So that's going to process a bit. While that's processing, let's go to the lab folder and talk about a couple of things. So if I go to my OneDrive and go into this class, inside of this class in lab 2, I've downloaded the data from the 10-meter DEM and the 5-meter. They're all zip files. Okay, so I'm going to right click on the first one, and I'm going to just extract here under use 7-zip. You could also just say extract all. I'm going to extract here. And you see that spit out 2 files, a .tiff file, which is called a geotiff file. The geo part of it is that TFW. It's a world file. It gives it its the coordinate system information. And then also has a metadata file, which could also help you with figuring out things that I asked you in that table. Once that's done and you see that this is working in GIS, probably can delete the zip file to save space. But let's make sure it works. Okay, so I've gone to ArcGIS Pro, and what I always recommend in your labs is that you're saving to your UVU OneDrive, and so that's what I'm doing here, Toke Lab 2, so I'm going to open that up. Okay, so it's open, And now I open up this and see if I can drag this TIFF file in here and if it's working. It should be building pyramids and building a statistical table. And I can see those pyramids are showing up and they're building here on the fly in the OVR file. So we can efficiently zoom in and out looking at this DEM. Boom, it loaded. Once it's loaded, I'm going to delete my zip file that corresponds to save space. Okay, so the Tokay Lab 2 folder that you see is actually the folder for this ArcGIS Pro project. So I'm not putting files inside of that. I'll put the, this is the Arc Pro APRX file folder. And so I'm keeping all the like geotiffs outside of it. Inside of that, there will be a geodatabase, of course, and the APRX file and all that. You can save to the geodatabase. It's recommended in some cases. I'm not too worried about it right now, as long as we're saving things to OneDrive. Okay, so I'm going to extract here for the other ones too. So I'm going to, now when I did that, you see that what happened is a new file with that same name appeared and it's .asc. ASC is called an ASCII file, I believe, or, well, I'm not exactly sure if I had that right, but the file extension, it's a grid type, so it's a DEM type file. We can see that we saved a lot of space, went from 17 megabytes to 125. But what didn't pop up was a TFW or any sort of world file. This ASCII file does know where it is in space, or it has that spatial information. But when we load it in here, we're going to get an error, I think, about its spatial information. So it's building some pyramids again. And now it's loaded. Can't see where it is. Oh, there it is. Yeah. It knew where it was. But if I right click on it and go to properties, some of you may have received this error, especially if you loaded it as your first file. If you go to the source and look at the spatial reference, it says unknown coordinate system. All data like this that's coming from the Utah AGRC is going to be in NAD 83 UTM zone 12. So what you can do to fix that, and you'll have to do this for each of the files. So I'll show you how to do that in a second in a batch process. So first, let's unzip the rest of these. Extract here, make sure you're doing different ones each time. And then I should be able to select all of 3 of these, pull them in. And then I'm gonna trust that it's gonna work. And I'm gonna save time deleting the zip files. Okay. So as those pyramids are loading, I'm gonna go back to Open Topography and see how it's doing. So let's go to My Open Topo, Jobs, and it's still working. And I actually don't see my second job that I submitted, which is unfortunate. Refreshed, it didn't come back up. So I better resubmit that. Maybe I didn't quite press submit on my second job. Apologies. That's annoying. But these are things you got to do. Okay. So USGS, 1 meter. Select the region again. geotiff, hillshade, slope. 2020 Cedar Valley, Tokay 1. Submit. Okay, it has been submitted. Hopefully that's going to work. I'm going to open in a new tab, see if my jobs now show 2. Doesn't seem to, but therefore I'm going to keep this open and running in this browser. Sometimes, one thing that's true is the 3D data, 3D elevation program data is actually sourced off of another server, going to open topography, being processed. Sometimes it goes down, it's not available, things can go wrong. So keep that in mind. Okay, let's go back here. Now we've got all of our different data sets in here. We can see I have some areas that don't overlap. We're going to need to do a couple of things here, which is first we're going to mosaic these to new rasters. But first I need to go back and give them coordinate systems. So let me show you how to do that. So I'm going to stop this video. We're going to call this downloading the data video. And then the next video we will have is going to be defining projections of your coordinate systems for unknown coordinate systems of data sets, and mosaicing to new rasters, and then clipping a raster. Okay, so let's stop this video recording and we'll start another one for video 2.